See Standard 12th Max Chapter 6 XI 6.7 Applications of Vector Algebra. Let us have the introduction. Equation of a plane passing through two given points and is parallel to a non-zero vector. Let me take a parallel vector as vector C and 2 points as point A and point B on the plane. So in this case, we have to define the position vector of the point A as vector A and point B as vector B. So join this point. So on this line, you take an arbitrary point P, so whose position vector is vector R. Vector R. So in this case, in the parametric form, the vector equation of this line is vector R is equal to vector A plus S into vector B minus A plus T into vector C. See, again this B minus A becomes this vector, and this is parallel to a plane. So as we have seen in the previous case, equation of a line passing through a point parallel to two given vectors here. So this plane is also parallel to vector C and also vector A for the line AB, B minus A. In this form we write. So R, after simplification I can write also vector R is equal to 1 minus S into vector A. You collect the vector A and then S into vector B plus T into vector C. Same thing is related to the previous one. Now come to the non-parametric form. Non-parametric form. In the non-parametric form, we take that here vector R minus A is a point dot. For non-parallel vectors, we can take this vector C and this is AB line B minus A. The cross product that is vector B minus A cross vector C. Cross vector C is equal to 0. See, let me give you a small explanation. This is C B minus A here. This is parallel to the line and C is parallel to this line. So the plane is parallel to this cross product of the two vectors. So if two vectors are parallel, then the dot product becomes 0. This is the non-parametric form. So vector B minus vector A and vector C are non-parallel vectors Come to the Cartesian form. Take the point vector A as XI plus X2j plus X3k and point B as vector B Y1i plus Y2j plus Y3k and the parallel vector C as C1i plus C2j plus C3k. So therefore the determinant value x minus x1, y minus y1, z minus z1. Then next is x2 minus x1, y2 minus y1, z3 minus z1, z2. Z2 minus Z1, C1, C2, C3 is equal to 0. So this is the Cartesian equation of the plane. Using this, let us do the problem. Third and the fourth problem I am going to do. First, let us see the third sum. See the third sum. Find parametric form of vector equation and Cartesian equation of the plane passing through the points 2, 2, 1, 1 minus 2, 3 and parallel to the straight line passing through the points 2, 1 minus 3 and minus 1, 5, 8. See, the plane is passing through the two given point. Let me take the point vector as 2i plus 2j plus vector k. Next point as vector b. This is equal to vector I minus 2j plus 3k. See, and it's parallel to the line joining the points. So we take the parallel vector. See, parallel vector C as here. The point you have x1 minus x2. Anyway, you can take x1 minus x2 is 2 minus of minus 1 is plus 1 and 1 minus 5 and then minus 3. This is minus 8. So minus of minus 8 is plus 8. The point we get 3 minus 4, 5. So in the vector form we write C as 3i minus 4j plus 5k. So first they ask you in the parametric form. Parametric form is vector r is equal to 1 minus s into vector a plus s into vector b plus t into vector v. So substitute here vector r is equal to 1 minus s into vector a as here 2i plus 2j plus k. So 2i plus 2j plus k. S into vector b. Vector b is here I minus 2j plus 3k. Vector I minus 2j plus 3k. Then plus t into 3i minus 4j plus 5k. So this is the parametric representation of the vector equation of a plane. Next is Cartesian form or Cartesian equation also we say. See, determinant x minus x1, y minus y1, z minus z1. Z minus z1, x2 minus x1, y2 minus y1, z2 minus z1 and then c1, c2, c3. Is equal to 0. So substitute the points. We take x1, y1, z1 point as 2, 2, 1. x2, y2, z2 point as 1, minus 2, 3. So here they given for you. This is vector form. Here they given the 2 points here. And then C point. C point just now we have got 3 minus 4, 5. C, C1, C2, C3 is 3 minus 4, 5. See, substitute in the determinant x minus x1, x minus 2, y minus 2, z minus 1. X minus 2, y minus 2, z minus 1. Then x2 minus x1. So 1 minus 2 is minus 1. y2 minus y1. y2 is minus 2, minus 2 is minus 4. Then z2 minus z1, 3 minus 1 is 2. And c1, c2 is 3 minus 4, 5. This is equal to 0. Simplify this. X minus 2 into, here you leave up this row and column, minus 20 minus of minus 8. So that you will get plus 8. Minus y minus 2 into, leave up this column and row, minus 5 minus 6. And then plus z minus 1 into minus z minus 1 into minus 1 minus 4 plus 4 minus 12 is plus 12. Plus 12 is equal to 0. See, after simplifying this, you will get the answer as here 12x minus 11y minus 16z plus 14 is equal to 0. You can simplify and write this answer. See the second sum. Find the parametric form of vector equation and Cartesian equation of the plane passing through the points 2, 2, 1, 9, 3, 6 and perpendicular to the plane given. See the points. First let me take the points. Vector A as 2i plus 2j plus vector k, and vector B is 9i plus 3j plus 6k. And see here it's given our plane is perpendicular to the plane. Actually the plane form is vector r dot n cap is equal to p. Previous exercise we have seen. So vector r is xi plus yj plus zk, and normal vector is here the coefficients 2i. Normal vector is 2i plus 6j plus 6k. So this normal vector here is perpendicular to this line, but the same normal vector become the parallel vector of our required plane. So let me take this vector as the parallel vector 2i plus 6j plus 6k. Since this is the normal vector perpendicular to this plane, but this perpendicular these two planes are here perpendicular, therefore this normal vector become the parallel vector of our required plane. So first let me take the parametric form. Vector r is equal to 1 minus s into vector A plus s into vector B plus t into vector C, whereas t are scalars, they belong to R. So substitute here, vector r is equal to 1 minus s into vector A is 2i plus 2j plus vector k plus s into vector B is 9i plus 3j plus 6k, then plus t into vector C is 2i plus 6j plus 6k. Next is Cartesian form. X minus x1, y minus y1, z minus z1, x minus x2 minus x1, y2 minus y1, z2 minus z1, c1, c2, c3 is equal to 0. So you take x1, y1, z1 as the point. First point here 2, 2, 1, 2, 2, 1. x2, y2, z2 is second point here 9, 3, 6. Next is parallel vector. C1, C2, C3 is equal to parallel vector is 2, 6, 6. 2, 6, 6. So substitute here x minus x1 is 2, y minus y1 2, z minus z1, z minus 1. Next is x2 minus x1. 9 minus 2 is 7, 3 minus 2 is 1, 6 minus 1 is 5. 2, 6, 6 is equal to 0. See, this is the Cartesian form of the equation of a plane.